So we are going to go over constructing square root of 2 on a number line. And when I say constructing square root of 2, when we say the word constructed, we're very precise, right? We're not just saying like, oh, I think it's like right here, right? It has to be very, very like, what's the right word? Precise is the word that I'm thinking. So the way I'm going to build this is I'm going to build this using our construction tools, which is right here. And I'm basically going to build it off of our famous triangle, 45, 45, 90 triangle. So just as a reminder, I'm going to pretend to build one. And it's not going to be exact, but I kind of want it to like mimic this. So this is going to be one of the sides. So it's going to be one unit this way, right? And then I'm going to make this guy perpendicular to this guy. Hence, that should tell you what tool I'm going to use and pull from here. And then because this length and this length are supposed to be the same, they look pretty good. And then I'm going to connect these two and these. So this is going to be my 1 square root of 2 triangle. So let's write that. So this will be the length of 1 because that's my 1 right here. I'm going to get this length to be the same. So I'm going to put another 1 here. So therefore this is going to be my square root of 2. Square root of 2 length on this side. And so once I have this square root of 2, then I can copy this segment so that it starts here and ends wherever it ends. So this is my job. My job is going to try to build this thing. So anyone, what's going to be my first tool that I'm going to grab over here? What's my first tool that I'm going to grab?
Segment.
Yep. So segment goes here. It goes from here to here. And then you guys do this thing that I really like. You select it and you make it like a different color so it'll stand out a little bit. Oh, that's not standing out so much. Hold on, let's try that again. Make it darker. Oh, that's pretty dark. Okay. And then I'm going to copy. I want to copy this segment, except for I want it to go this way. So what is my next tool that I'm going to use? There's 2 things that I just said. I want it to be like this. I don't want to say that word, but I want it to be like this. So it is a 45, 45, 90 triangle. But I also want this segment to be this. So there's 2 tools that I could be searching for right now. And either one, it's like, making your bed or brushing your teeth. It doesn't matter which one you do first. So which is my next tool? So someone said parallel, and actually it's not parallel. We're not going to use the parallel line. 2 people actually said that. So we're not trying to make it parallel to this, right? I don't see any parallel lines here. Yeah, I'm actually going to grab my perpendicular tool. That's one of my tools that I'm going to use. So if you don't know where perpendicular is, you click more tools, you click perpendicular, and it says, now you have to choose things. Choose a line to set the slope. Now, if I want it to be perpendicular to this line, then I'm going to choose this. So now I can put it anywhere. So now it says choose a point to set location. Do you want it here, 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 here? Now it really doesn't matter where you put it, but just because I set it up like this, I'm going to put it right here, which corresponds to here, right? And it matches to here. So far you should see this like 90-degree angle here. So we have this 90-degree angle here, which I didn't label. So I should. It's going to bug me until I get it labeled. I'm going to pretend that's a perfect little square in there. So now I have a 90-degree angle here. I have a 90-degree angle here. What's the next tool that I need to pull to use? Yeah. Sorry, what?
I said compass.
Yeah, 2 people said it. You said it, and then someone in the chat said it. So I'm going to grab my compass tool, and it says choose a segment so that it's your radius. Now, in reality, in this whole entire paper right here, I'm pretending this is a paper, I only have 1 segment. It's this guy. But the reason why I'm choosing this is because I want to copy this segment. And the way you copy segments in construction land is you use circles. So I'm going to choose this, and now I have a circle that I can put anywhere, right? So I want to put it right here, centered at this perpendicular intersection, right? And if you notice here, it's the radius is here, which it should, because that's the one I just grabbed. And then also has a radius here. So if you know about a circle's radii are always congruent, right? So all the radii of a circle are congruent. So this guy's congruent, this guy's congruent, this guy's congruent, they're all congruent to each other. So if you kind of look, I have this guy now, and I have this guy, and this guy. What's left? What's left? What's the only thing left to do? Yeah, the square root of 2. So all I'm going to do is I'm going to connect these two here. So I'm going to make a segment. I'm going to connect these two here. I'll leave it blue. Why not? Okay. So this is my length of square root of 2. And I'm like, yay, that's a square root of 2. So when I zoom out and I look at all of your pictures, when I go into this teacher mode, I should be able to see this picture. And your eyes are very well trained, right? Your eyes are so trained that you can tell that this is perpendicular to this just by gut instinct, because you look at corners that are perpendicular all the time, right? If you look around your room, if you look around your computer screen, I'm looking at my computer screen, I see like this right here. You see how this is perpendicular to this edge right here. So there's all kinds of perpendiculars. Your eyes are very trained to see that. So I should be able to see this without you guys labeling anything, but I'm not done because it says construct square root of 2 on the number line. So where is square root of 2? How do I look for it here on my number line? So this is square root of 2 here, right? So it matches this guy here, right? So I basically got to get this segment and push him down so he's right here. So what do I do next? How do I get that segment down? No? So what we're going to do is we're going to copy this segment. How do I copy a segment in construction tools? How do I do that? What tool should I grab? Yeah, use the compass again. Okay, so I'm going to grab the compass again, and it says choose a segment. So I'm not going to choose this one because this is radius 1. I don't want radius 1. I want radius root 2 right here. So I choose this, and then it says, where do you want to put it? Where do you want to put the circle? So I want to put the circle here, starting at 0, because then the length of this segment from here to the outer circle, from here to here, will be square root of 2, right? So I'm going to change this circle blue so that it matches this radius here. Does that make sense? And then I just want to add this little point guy right here. And then I want to label him. So I go back to select. I click the label and then I say, hey, I want to label you. And I'm going to write square root of 2, which some of you fancy people realize that you can copy and paste from Desmos onto here and it'll give you the symbol. I think that's what you guys said. So there goes. That's how I find square root of 2. Okay. Square root of 3 would be similar, except for instead of using the 45, 45, 90 triangle, we are now using the we're using the 30, 60, 90 triangle, which is 1 on one side, 2 as my hypotenuse. It goes like this, 2, and square root of 3 would be the other leg. So very similar touches there. So does that make sense? Any questions on this? So the question you should be asking yourself, because we do have a quiz today, and you have to construct things like this. You should be asking, okay, well, why did she have to use 1 square root of 2? Is there another way to do this? And the answer is yes, there's another way to do this, but this is the most accessible way that comes to my brain when I think about square root of 2. Okay, so let me pause really quick so that I can get the other. So our second one that we want to construct is something called is 1 plus square root of 5. Now, so some of you are thinking like, oh, can I do square root of 5 because I can get square root of 2 plus square root of 3? The answer is no, right? If you're adding two things together, adding things together is a lot more difficult than multiplying. I know that sounds weird, but think about adding fractions, right? Think about adding variables and like terms, right? Like in order to add x to something else, it has to be a like term, meaning they have to be this of the same kind. So I can't add square root of 2 plus square root of 3 to get square root of 5. That's a no. That's a huge fail, right? So how would you get a square root of 5? Like, how could I get a square root of 5? So I want to remind you that whenever you see these square roots, most likely you're in the land of right triangles. And when I say right triangles, your brain should go in two different directions, right? Anybody know what two concepts or topics I'm going to say right now? One of them you learned in 8th grade, and then the other one you learned in geometry. So that might have been like integrated 2 or integrated 3. So what are the two concepts that you should be thinking of when I say right triangles? What are the two concepts? Yes, very good. Number 1 is Pythagorean theorem, and number 2 is trig. Okay, so here I don't necessarily want to do trig. I don't want to necessarily do trig because sine, cosine, and tangent, I don't see that here in what I'm trying to build, but I definitely see my Pythagorean theorem. So Pythagorean theorem says when you have a right triangle, we have a squared plus b squared equals c squared, c being the length of their hypotenuse. Give me 1 second. So we're going to use the Pythagorean theorem to build this. Now, when I see 1 plus square root of 5, I don't really care about the 1 plus because I can do the 1 plus. The 1 plus is like this, watch. 1 plus whatever. So think about this as like you going for a run, down this, very straight road. You run a mile. You are running a mile because Miss Johnson, she doesn't like running. So, but anyways, you run a mile, you take a break, you tie your shoes, drink some water, maybe you do push-ups, maybe you do a couple burpees. I don't know, whatever you're doing. And then you're going to run square root of 5. And you're like, Miss Johnson, I would never measure anything in square root of 5. I understand that, but when I talk about this, then this makes a lot more sense, right? So you ran 1 mile plus a square root of 5 miles. Okay, so just pretend this is another number. So you ran 1 plus 2 miles. Oh, that's 3 miles altogether, but it's a square root of 5, so it's an irrational number, right? So I'm going to construct, so I'm not really thinking about the 1 plus part. I want to construct a triangle using numbers where I get out a square root of 5. Now, don't think there's only one answer to this because there's many. There's many right triangles that can have a length of square root of 5. Okay, so the first thing I'm going to do is I'm going to erase my square roots of 5. I mean, my other numbers here. And I'm just going to use this same triangle because I can. And just don't look at it as don't look at this anymore as a 1, 1, root 2 or a 45, 45, 90. Look at this as a right triangle, and one of the side lengths is square root of 5. So can you think what numbers would fit together? How could you do this? So I'm going to write a couple of things. So I'm going to like annotate because that probably would be, oh wait, maybe box. Okay, here. I'm going to go like this. So I want you to think something squared plus something squared equals something squared. So let me annotate a little bit. So here's the equation that's going on in my head. This is the Pythagorean theorem. Good. So I want to put square root of 5 into one of these. I don't know, either here, here, or here. And then manipulate the numbers so that it would be a true equation. And I would really like if the other two numbers were not irrational. I would really like if they were whole numbers, because then I could build it on my construction. So what are those numbers, y'all? What numbers can we use? Okay, so obviously I'm going to put a square root of 5. Do you want a square root of 5 here? Do you want a square root of 5 here? Do you want a square root of 5 here? Where would you like it? As a leg or as a hypotenuse? There's no wrong answer. Just choose one. Perfect. Someone says hypotenuse. I'm going with hypotenuse. There it is. Okay. Someone tell me what's square root of 5 squared while I write this here. Yeah, it's 5. Okay. So now I'm looking for what squared plus what squared can give me 5. So think of two numbers, one here, one here. What squared plus what squared equals 5? Oh, 2 and 1? Okay, 2 and a 1. I don't believe you. 2 squared is 4 plus 1. Yeah, that's right. So I'm going to put a 2 here and a 1 here, and then that's all I need to do in order to construct this. Does that make sense? Seems really ambiguous, but this is where all of the thinking comes, because the rest of this is just you constructing. So I'm basically going to build a triangle that goes 2 this way, 1 this way, and then the square root of 5 will go this way. I'm not sure if 2 will go this way. I don't know. I'm going to build 2 this way just in case. Okay. So I'm going to switch these two numbers just because I want to make sure it fits on my diagram here. All right. So I'm going 1 this way and 2 this way. I'm going to pause the video. Can you already construct 1 this way, 2 this way, and then give me my hypotenuse and then pause right there. So I'm going to say this again. I want you to build 2 this way. I want you to build 1 unit this way. Grab your hypotenuse and then pause, because we'll finish that. Okay, so you built the 2 going this way, boom, boom, right? You built the 1 this way. And so remember, I told you earlier, you can do perpendicular first, you can do the compass next. It doesn't really matter which way you go. So I think we did, what did we do first last time? Did we do compass first? We did compass first. So let me just show you doing perpendicular first and just show you, it doesn't really matter which one you do. So I'm going to go perpendicular. Oh, I need to do segment first. What the heck am I doing? Let me do segment first. Let me turn that black like I did last time so it stands out, right? So there's my 1 unit. I'm going to build a lot of stuff off of here. I'm going to be able to build my 1 off here. I'm going to build my 2 off here. So I'm going to do the perpendicular segment first. So set a slope. Now it's perpendicular. So now if you see I have this, I think I did the compass first, because now this looks familiar. But anyways, it doesn't matter which one you do. So now I'm going to go through and I'm going to hit compass, and I'm going to go with the segment. And I'm going to put 1 here. So now that's my 1 unit. But I'm also going to put 1 right here, because now that's my 2 units. So if you got this far, this is pretty good, because you have 1 unit this way. You have 2 this way. Does everybody see that? I have 1 this way. I've got 2 this way. You can label this as 2 if you'd like. I'm not going to label it as 2 because you can actually see this. The next thing I am going to do, so here I built the 1, I built the 2 this way. Now I need my hypotenuse, which goes from this intersection here to this intersection right here. So I'm going to grab my segment, which goes from here all the way to here. Okay, so does everybody see my 1, 2 square root of 5? And maybe I'll label that here so that this is very concrete for you. So this is 2. I'm going to go like this so you can see how this is the length of 2. And this is square root of 5 here. So this is square root of 5. You know what I'll do also? You don't have to do this. I just want it to highlight for you so you can see it. You can see my triangle in there. Oops. So does everybody see my triangle in there? This is a 1, 2, root 5. So because I have my square root of 5 now I can deal with the 1 plus square root of 5. So the next thing I'm going to do is I'm going to grab my compass and I say choose a segment, clearly I'm going to grab my square root of 5, and it's really large. And you can always check to make sure that you grab the right segment by measuring it, putting the center on one. And do you see how I can't point to it because once I move my circle, right, my circle will move. So you can see that the end of the end point of the segment, one of them's on the center, and the other one is on the end of the circle, at the circle, right? So I could put this anywhere I want. So this is where placement makes sense, right? So placement makes sense that it's going to be 1 plus square root of 5. Okay. The most logical place that you'll want to put it is at 0, because then that'll be square root of 5, the end of that circle. But no worries. But you can also put it at the end of 1 or at 1. So if I put it at 1 right here, like I just did, now let me make it blue just so that circle stands out to you. So when I put it here, when I centered my circle here, what that just did is I ran that length of 1 mile. I did 10 burpees, and then I continued running for square root of 5. So then I say, what's the total amount of length that you ran? You'd say 1 plus square root of 5, right? So let me just label this first, and I'll give you one more understanding of that. So let me label, and I'll say 1 plus square root 5. Okay, so I'm just going to highlight some stuff just so that we're all on the same page. I'm going to erase my triangle, my triangle labels there, just so I can label a little bit more so you guys can see. So this right here is 1. You guys all see 1? Okay, and this right here, from here to here, is my square root of 5. So therefore that whole length is 1 plus square root of 5. So that is how you make constructions on Desmos. These constructions, if we were to do them by hand using a compass and a straight edge, it would come out exactly the same. The thing I really like about doing it on technology is that students would have to learn how to use a compass, and like it's this like funny thing about holding the compass, keeping it, not squeezing it, and then your pencil not, skewing across, your paper not slipping. There's a lot of like things that you'll have to learn dealing with a compass and a straight edge. But here, it's really just clicking buttons, and now we can focus on the learning of what's going on behind the scenes. So this is how we built 1 plus square root of 5. It's all based on the same thing. Though it was nicer about the square root of 2 one. Was it this one? Yeah, what was nicer about the square root of 2 one is you guys already knew 1 root 2. We already knew what triangle to use for the square root of 2. So if I give you something that's not square root of 2 or square root of 3, that means you're going to have to use this Pythagorean theorem kind of puzzle for you to figure out how would I build a square root of 5. So you put it in some place. Now you all put it here, but if I put it here, it still would have worked, right? So I would have had to think of another number that would have worked in all of this, right? So if you put a square root of 5 here, let's think 1. So it would be 1 plus 5 is the square root of, now that doesn't work because I can't build a square root of 6. And then I would just keep going until I found a number that would make sense. So for example, the next number I would have tried is 2. 2 plus the square root, 2 squared plus the square root of 5 squared is 4 plus 5 is 9. Oh, that's 3. So do you see how I could have built this? But knowing this diagram here, 2 is like way too tall for this too. So this wasn't the only answer, but this was the one that would fit in here really nicely.